All right, here's our next example. A baseball player hits a ball 3 feet above home plate. The velocity of the ball off the bat is 132 feet per second, and the angle is 40 degrees. If the distance to right center field is 370 feet, which it is at Minute Maid Park, and the height of the wall is 10 feet, which again it is 10 feet tall in right center field at Minute Maid Park, will it be a home run? Now, let's assume that the outfielder is only going to be able to catch the ball if it is less than the 10 feet height. We're not going to say this guy, leaps up and can catch it 16 feet up, right? So we're going to do the same thing that we did on the last problem. We're going to create a set of parametric equations and try to figure this out. So our horizontal position is going to be based off of the fact that our initial velocity is 132 feet per second times cosine of 40 degrees times t. Now remember, the t is outside of the cosine. Be very clear about that. And our y value, our y function is going to be negative. It should be negative 1/2 g. So we're using 32 feet per second squared. So negative half of that is negative 16 t squared. So that's the downward part, the downward force that we have for the y value. But the upward force starts off, he was hitting it at 132 feet per second. So the vertical part is going to be the sine value, so 40 degrees times t, plus the initial height. So he hit the ball 3 feet above home plate. That's when he connected with it before it went out. Well, did it go out of the ballpark, or did he just get out? That's what we're going to figure out. So we want to know, is this going to be a home run? All right, well, here's what we need to do. We need to figure out how long does it take for it to travel the 370 feet, right? So when it tells me 370 feet away, that is going to connect with that horizontal distance related to the x of t. So when I look at this, I draw a quick little picture. So here's my little dude, here's his baseball bat, and he hits a ball, and he hits it up, and is it going to cross over this 10-foot wall out here? Now from here to here, we know that this is 370 feet. So what we need to know is, how long does it take that ball to travel 370 feet? Because once I know what that t value is, I can plug that into my y of t function and determine what will be the height of the ball, the y value, when we're 370 feet away. All right, so let's work that out. So that means I need to figure out, when does 132 times cosine of 40 degrees t equal 370 feet? Well, this is just a matter of solving a linear equation. So t is 370 over 132 times cosine of 40 degrees. Always make sure that you double check to see that you were in the correct mode. So we were still in degree mode because that's where we were last time. Okay, that's good. So we have 370 divided by, now you gotta be careful about this. You gotta use parentheses. 132, still in parentheses, cosine of 40 degrees. That closes off the cosine, that closes off the denominator. All right, so it tells me that the t value is approximately 3.659 seconds. So I just need to know, where is the ball vertically at 3.659 seconds. So now we're going to find y of 3.659 seconds. All right, so I'm just going to quickly store this in for my variable, and then we're going to evaluate y of that value. So negative 16 t squared plus 132 sine of 40 degrees plus 3. Let's see what we get. Oh, that is not good. It seems that this ball is going to, well, we know it's not going to go under the ground, but it's definitely not going to clear the fence, right? So will it be a home run? No. Well, how far out will it get? Now we could, definitely solve this and say, okay, when does this equal 0? We could solve that quadratic equation and see what we come up with. You know what? I'm going to, since I've got the calculator here, let's see what we can do with that. If I go to my math, numeric solver, let's check this out. So I want to type in negative 16 t squared plus 132 sine of 40 t. Did I do that right? Oh no, I forgot to put my t in there. Felt something was off. All right. How about we try to put the t in here now? Let's see if that'll make a difference. Oh, okay, that makes a big difference. Boy, you gotta be careful about how you type things in. So, is it a home run? I'm gonna say, yes, that's a home run. Because when it clears it, it's gonna clear it, it's gonna be 89 feet above that. I just forgot to put in the t. That is that's definitely a deal breaker. But if I were to, nope. If I were to solve that though, let's see if it still has what, okay, so I have this plus 3, and I want to know when is it going to hit the ground. And so let's solve this. So it tells me that the t value for solving that, the right bound one, is going to be in 5.34 seconds. So yeah, should definitely be good. It won't be back to 0 feet for quite a while. But let's graph this and see if we can get a good idea about what's going on. And we'll do 132 cosine of 40 degrees t, negative 16 t squared plus 132 sine of 40 degrees t plus 3. And I'm actually going to do another one just so we can see like where the fence would be. So x is just going to be t, and y is going to be 10. We're going to go from 0 to, say, 3.659. That t step should be good. The y min, or the x min is 0. X max, we're just trying to see at 370 feet. And we can do this every 10. The y min is 0, and the y max, not sure how high that'll be. But let's say 400, see how that works. Oh, that's definitely a bit much. Say 120, and let's change this to, so there's the baseball. Oh, that, I guess I didn't set this up very well. Yeah, so is it going to clear the wall? For sure. I mean, this is an upper deck one. Yeah, I totally crushed it. Well, here's the thing. There's crushing the baseball, but there's also making sure that you hit it at the right angle. If it's too low, it just won't have enough lift in order to carry it over the wall. If it's too high, it won't have enough forward momentum, and so just go up and come down, easy out, right? Easy out. Oh, that was my nickname when I played baseball growing up. Interesting.